Good morning, children. Children, today I am going to start chapter redox reactions, and in today's video I am going to tell you about oxidation and reduction reaction, oxidizing and reducing agents, and some rules to find out oxidation number in a compound for an element. So let's start. Oxidation reduction reactions. Children, oxidation reduction reactions are also called redox reactions, and redox is an abbreviation used for terms oxidation and reduction. Red has come from reduction and ox has come from oxidation. This is how redox term is formed. All redox reactions involve the transfer of electron from one atom to another. We are going to understand if any atom is losing electron, what is happening to this atom, and if the atom is accepting electron, what is happening to that atom. Children, spontaneous redox reactions are generally exothermic, and we can use their released energy as a source of energy for other applications. And one such redox reaction you must have heard, combustion reactions, which are usually exothermic reactions. Now next. Children, oxidation reduction reaction concept on the basis of gaining and losing oxygen. Oxidation reaction are all those reactions where you are seeing any atom in a compound is added with oxygen to form product. For example, if you are seeing here, the natural gas is burning here. Natural gas means methane is combining with oxygen molecule. What is happening to carbon atom in methane? Carbon is added up with oxygen to form carbon dioxide and water is released. So what is happening to carbon here? Carbon present in methane molecule is turning up into carbon dioxide. That means we are saying carbon is oxidized, or carbon present in methane molecule is oxidized. Reduction reaction. Reduction reaction is exactly reverse of oxidation. Reduction reaction is the reaction of releasing oxygen. Cupric oxide is turning up into copper on passing hydrogen gas over it. Oxygen is removed from cupric oxide to turn up into copper. This is why we are saying this copper oxide is undergoing reduction reaction. So this is the concept on the basis of accepting or losing oxygen. Now children, all the reaction where you are observing, where you are seeing there is a addition of oxygen happening, or there is a addition of any other electronegative element is happening, or any one element where you are seeing the hydrogen atom is removing, or any electropositive element is removing from the substance, that means that substance is undergoing oxidation reaction. Similarly, if you are seeing or if you are told that reduction reaction is happening, that means in that reaction what must have happened? Oxygen must be removed from the substance, or any other electronegative element must have removed, or there must be addition of hydrogen or any electropositive element to the substance. This is how we used to recognize how the substance is categorizing into the oxidation or the reduction reaction. Children, on the basis of gaining and losing electron, if you see carefully, this is the combination reaction where the sodium and chlorine is combining to give you sodium chloride. We usually say if sodium is transforming into sodium ion, that means it is losing one electron. turning off sodium into sodium ion, or turning up of any element into cation. That means it is undergoing oxidation reaction. Or turning up any element into anion, or here Cl2 is turning up into chloride ions carrying -1 charge. That means the reduction is happening with Cl2. So when any atom is acquiring positive charge, that means it is undergoing oxidation. If any element is acquiring negative charge, that means it is undergoing reduction. Now, oxidizing and reducing agent. Children, oxidizing agent, on the basis of oxidation number, which we are going to learn just after this slide, is the reagent where you are seeing there is an increase in oxidation number, are called oxidizing agents or oxidants. The reagents that lower the oxidation number of a element, all those reagents are called as reductants or reducing agents. Or children we can say here, oxidizing reagents are those reagents which reduced themselves and oxidize others. Similarly, reducing agents are those which are undergoing the oxidation process themselves, but they are reducing others. This is how we used to call oxidizing and reducing agent also. So children, we can say here oxidation and reduction must occur simultaneously. If we are saying one atom is losing electron, that means some another atom must be there to accept that electron. So we can say here the reactant that reducing an element in another reactant is called reducing agent, and the reactant that oxidizing an element in another reactant is called oxidizing agent. Now children, oxidation number. Children, oxidation number of any compound is defined as the number of electric charges it carries. And you can assume like the complete electron transfer is happening in case of covalent bond 2. We are very much understood the ionic compounds are the compounds which are formed by the transference of electrons in between the two elements in a compound. So we can easily recognize what kind of charge must have acquired after the combination of two elements to become an ionic compound. But here to find oxidation number, we are assuming here if the compound is covalent also, what charge, what electrical charge one element in a compound must be carried. The calculation of that charge is called as oxidation number. And on the basis of oxidation number, now we are going to understand whether the compound is undergoing oxidation reaction, whether the element present in a compound is undergoing reducing or reduction process. Now the rules by which we are going to assign oxidation number to the element present in a compound. The first rule is saying the oxidation number of each atom of an element in free state is 0. That means if you are seeing any molecule in a diatomic or triatomic form in a reaction, you will say the oxidation number is 0 of that element. For example, oxidation number of hydrogen in H2 is 0, oxidation number of Cl in Cl2 is 0, oxidation number of oxygen in ozone is 0, oxidation number of sulfur in S8 is 0, and so on. For example, children, the elements which used to exist in monatomic form like calcium, sodium, potassium, these all are the all the elements which are metals, and they usually exist in a monatomic form. So when you are seeing reaction like Na plus H2O gives NaOH plus H2, if you are told to calculate the oxidation number of sodium here present as a reactant, so the oxidation number of sodium in that case is 0. Now the next rule. The next rule is saying the oxidation number of an atom in a monoatomic ion is equal to its charge. For example, if you have heard alkali metals present in group 1, and let's take two examples, sodium and potassium. Sodium and potassium are the metals which used to acquire always positive charge because they used to lose their electron to form ionic compound. Ionic compounds like NaCl or KCl. So oxidation number of sodium in sodium chloride is +1. Oxidation number of potassium in potassium chloride is +1. And the alkaline earth metals which were present in group 2, and the alkaline earth metals like calcium, magnesium, they used to have oxidation number +2. For example, if you are saying I have one compound MgCl2, oxidation number of Mg in MgCl2 is +2. Or any other compound like calcium carbonate, oxidation number of calcium in calcium carbonate is +2. Aluminium is considered to have +3 oxidation number in its all compounds. Third rule is the oxidation number of oxygen is usually -2, children. It is usually. But if you are seeing any peroxide linkage where two oxygen are bonded with single bond with each other, and at the end of two oxygen atoms there will be a bonding with other atoms, in that case you will get oxidation number of oxygen atom is -1, -1 respectively. And in case of superoxides, like potassium superoxide, you will have oxidation number of each oxygen atom. Superoxide like KO2. So O2 is the one which is having -1 charge, and both the oxygen atom having oxidation number 1/2, -1/2 and -1/2. Another exception is OF2 molecule. Children, you all know fluorine is the most electronegative element in the periodic table, and it is more electronegative than oxygen. So we will always take fluorine oxidation number as -1, and in case of OF2 the oxidation number of oxygen here is +2. Now rule number 4. The oxidation number of hydrogen atom is either +1 or -1. If hydrogen is bonded with non-metals like Cl, Br, F or H2O, if it is bonded with non-metals, then the oxidation number of hydrogen atom is +1. And when it is bonded with metals, it will possess oxidation number -1. For example, you have hydride like sodium hydride, NaH. Here the oxidation number of sodium is +1 and oxidation number of hydrogen is -1. Now the next rule, the oxidation number of fluorine is -1 in all its compounds. It remain -1 if you are seeing fluorine present in any compound. And the halogens like Cl, Br and I usually exhibit oxidation number -1 in their halides, and generally halogens like Cl, Br and I, if they are bonded to oxygen, they used to show oxidation number +1. And the reason is because oxygen is more electronegative than halogens like chlorine, bromine and iodine. That is why oxygen used to show oxidation number -2 there, and chlorine, bromine iodine present in the compound containing oxygen atom will show oxidation number +1. Next rule is the algebraic sum of oxidation number of all the atoms in the neutral molecule is 0. That means if you are adding all the oxidation number of the elements present in the compound, the summation of all the oxidation number, it has to be 0 if you are talking about the neutral molecule. And if you are talking about an polyatomic ion, then the algebraic sum of oxidation numbers of all the atoms in polyatomic ion is equal to the net charge of an ion. For example, let's take example like ClO3 minus 1. It is a chlorate ion which is having charge -1. So the summation of oxidation number of 1 Cl atom and 3 oxygen atom should come equal to its charge, and that is -1. The next rule is saying when 2 or more atoms of an element are present in a molecule or ion, oxidation number of atom of that element will be the average atomic oxidation number of all the atoms of that element in that molecule. Children, generally after applying rule from 1 to 5, we used to determine oxidation number of the atoms present in various molecules or various polyatomic ions. And now in the coming lessons, in the coming classes, we are going to learn how to calculate oxidation number of a particular element present in the compound. So children, this is it for today's video, and in next class we will going to learn how to calculate oxidation